In the last video, we talked about our second parabola problem. Now we're going to move on to a third one. This is probably a bit more complicated than what we've seen previously. Now, you've got to find the focus, directrix, and axis of the equation y equals minus 4x squared plus 3x. Now, this is a different scenario for us because for the first time we've got a factor multiplying the squared variable of the parabola. And this is something we need to tackle. But the same principles apply as we have before. We still want to rearrange this equation in such a way to resemble the standard equation, i.e. rearrange this in such a way that one of the variables squared is equal to a constant times the second variable of the equation. Previously, the only alterations we've seen to this equation is that you have, for example, numbers added and subtracted to the y and x parts of them. You may have had, for example, y minus 1 squared equals some constant times x minus 3. Those small additions and subtractions of numbers within these equations are not all that troublesome. But as you'll see with this, when you have an actual factor multiplying the square variable, that's when you have a bit of a problem, because if you see, the only multiplying of variables is on this side, where you have a constant multiplied by the x, but you don't have any number here multiplying the square variable, and that's what we don't want. We don't want for any number to multiply the square variable. If there is any multiplying, we want it to be between the constant and the non-squared variable. In this case, the squared variable is the x, and the non-squared variable is the y, obviously. So how do we deal with this new minus 4 factor that's multiplying the square variable, which we obviously don't want? First, we factor out the minus 4. That results in this equation. Y equals minus 4 multiplied by x squared minus 3 over 4. We move the minus 4 over to this side. Hence, we're moving all the multiplying towards the non-squared variable of the equation, like we have here. There's no multiplying of the squared variable, there is multiplying of the non-squared variable. That's what we're doing here. We're moving the quarter factor over to the y side of the equation. Once this is done, the problem becomes a bit more straightforward. We complete the square, like we always have in previous problems. We do a bit more manipulation of the equation. The end result is this red bit I've highlighted here. X minus 3 over 8 squared is equal to minus a quarter times y minus 9 over 16. This now resembles what we've discussed previously, and it resembles the standard equation. You've got you've got one of the variables raised to power 2 equal to a constant multiplied by the other variable of the equation. I mentioned that in this case 4a would not be 1, and it isn't. 4a is actually minus a quarter, and hence a is equal to minus 1 over 16. So you see, all of this is centered around the same principal concept. You just want to rearrange messy equations to make them as similar to this standard equation as possible. Now, where do we proceed from here? Again, like we have previously, I like to think, what does the parabola look like? We know from previous knowledge that y equals x squared looks like this. It's an upward facing u. We've got y equals minus 4x squared plus 3x. So instead of an upward facing u, it's going to be an upside down u, like I've labeled here. Our next step, what is the vertex going to be? It's going to be 3 over 8, 9 over 16. Why is it going to be that? Well, look at this working out here, okay? Let's look at this line. What's the minimum value that this squared expression can take? It's obviously 0, and it takes that value when x is 3 over 8. Hence the vertex, I deduct, has x coordinate 3 over 8. When x is 3 over 8, what value does y take? Y takes the value 9 over 16. Hence, the vertex is 3 over 8, 9 over 16. Now we know what this vertex is. What's the axis? As we know, as usual, the axis goes through the vertex of the parabola and splits the parabola into two symmetrical parts. We know in this case that it's a downward facing parabola. Hence, the axis is going to be a vertical line going through the vertex 3 over 8, 9 over 16. Because it's vertical, we know it's going to be x is equal to something. that something is obviously 3 over 8 because it goes through the vertex. We've got a point that lies on the axis. What about the focus? The focus is 3 over 8, 9 over 16 plus a. Why is it that? Remember, we said if you know what the vertex is, the focus is going to be a units away from the vertex along the axis in the interior of the parabola. So in this case, it might be somewhere here, rough diagram. Okay, that's going to be 1 over 16th of a unit. Right? So if we know the vertex is 3 over 8, 9 over 16, we know that the focus will be a units below that, vertically below that. Hence, it's going to be 9 over 16 minus 1 over 16, which is a, to make 3 over 8 half. So that's our focus. What's our directrix? We talked about the directrix being a fixed distance, a, away from the vertex in the exterior of the parabola. And we said it was going to be perpendicular to the axis. So, if we know the axis is vertical, the directrix must be horizontal. Because the directrix is horizontal, we know it must be y equals something. We know that the distance between the vertex and the directrix is going to be a, which is 1 over 16. Okay, so in this case, we're going to subtract, in this case, the directrix is going to be a units above the vertex. In this case, it's going to be vertically up here. Hence, we say the directrix is equal to 9 over 16 minus a, which is 9 over 16 plus 1 over 16, which is equal to 5 over 8. So, we have the vertex, axis, focus, and the directrix. As you can see, there is a fixed routine to these problems, but they do require just a little bit of lateral thinking, and more than that, a bit of graphical thinking. After you've done the manipulation of the algebraic side to bring it into standard form, you've often got to think to yourself, what does the graph of the conic section look like, and relate what you've uncovered on the algebraic side to the graphical side. But as you can see, it has a kind of fixed pattern. It has a normal routine that just needs a bit of adaptation depending on what problem you're facing. This is probably one of the harder problems we've seen. As I say, we must practice these equations to get them right and perfect our understanding for the exam. Another thing I will say, it's no good just watching me do these problems for you. You must carry out these problems yourselves. So, as you're watching these videos, do please carry out these equations as I'm writing them down. You'll realize that if you do them by yourself while I'm explaining it to you, you'll uncover, or you might uncover more easily, what you're finding difficult to understand and where you're going wrong. And it's excellent practice for the exam. We're going to move on now to ellipses. Thank you for listening.